In January 2026, a 12-year-old boy was dragged underwater at a Sydney harbour beach on a Sunday afternoon. Friends pulled him out. He didn't survive. Less than 24 hours later, a surfer at Manly lost his leg. That same day, an 11-year-old had his board bitten in half at DY Point. He wasn't hurt, but the bite mark was measured, 15 centimetres wide. Preliminary assessment: bull shark. By Tuesday morning, 40 beaches along the New South Wales coast were closed. 4 attacks in 48 hours. Surf Life-Saving Redrawing told the public to go to a local pool. "You talk to old people who have been surfing for 40 years, one surfer said from a car park at Crescent Head, and they say they have never seen so many sharks in the water. That quote is where this story starts, not with the attacks. Those are being covered everywhere, but with that sentence, because the people who spend the most time in the water are noticing something the official reports haven't fully caught up to yet. And when you look at what the science has been quietly documenting over the last several years, what those surfers are sensing starts to look less like fear and more like accurate observation. Bull sharks are appearing further south along Australia's coast than they're supposed to be. The researchers who study this don't have a single clean explanation for why. And the data, when you follow it to where it actually leads, raises a question that is more unsettling than any individual attack. What if the map of where these animals live is being redrawn? And what if no one is fully sure how far the redrawing goes? To understand what that means, you need to understand what a bull shark actually is. Because this species is different from every other shark in the water, in ways that matter. Bull sharks are not the biggest. They're not the fastest. What they are is the only shark species on Earth that can live indefinitely in fresh water. They regulate the salt concentration in their own blood and tissue to match whatever environment they're moving through. Ocean, estuary, river. They manage all of it. Bull sharks have been tracked thousands of kilometers up the Amazon. They have been found breeding in Lake Nicaragua, a landlocked body of water hundreds of kilometers from the sea. In early 2025, a resident of a Brisbane high-rise filmed roughly 20 of them moving through the Brisbane River from his balcony, moving slowly, unhurriedly, through the centre of one of Australia's largest cities. "I was surprised," he said. "It took me a while to realise what I was looking at. This is the animal that surfers on the Nesses Dulles coast are now seeing in concentrations that feel wrong. And the reason it matters isn't just that they're dangerous, though they are, and around Sydney, bull sharks are responsible for more attacks than any other species. It matters because their distribution in Australia has always been one of the most clearly defined boundaries in marine biology. They live from the Collie River in Western Australia, across the north and down the east coast, to roughly Sydney. That's where the warm water ends, historically. That's where the thermal boundary sits. And that boundary is the whole story, because everything in what follows comes back to one number, 20 degrees Celsius. Below that, bull sharks can't function properly. Digestion slows. Growth stalls. The biology stops working the way it needs to. 20 degrees is the floor, the map was built around it, and for decades the map held. Now here's where something unexpected enters the picture. In 2023, researchers from Nestabulalu Department of Primary Industries and Macquarie University published the results of the largest bull shark tagging study ever conducted. 233 sharks, 21 beaches across New South Wales, 5.5 years of acoustic tracking data. They weren't looking for a range shift. They were trying to understand when and why bull sharks appeared near swimming beaches, what conditions brought them into the near-shore zone, how to predict their presence, how to reduce the risk to people in the water. Useful, practical research, but buried in the spatial results was something that stopped them, a confirmed detection at Merimbula. Merimbula is a small coastal town on the Nesses Dulles south coast. It sits at 36.9 degrees south. That is the southernmost confirmed record of a bull shark on Australia's entire east coast. And it wasn't summer. It was autumn, the season when, by every established model, a bull shark that far south should already be heading back north. Instead, a large male was sitting there, in water that the old maps said it had no reason to be in. One data point doesn't rewrite a map, but it asks a question. And the question is, if the boundary has always been around Sydney, what is a bull shark doing at Merimbula? The answer starts offshore, with a current most people have never heard of. The East Australian Current runs south from the Coral Sea, carrying warm tropical water down the continent's eastern flank. It's been running for millions of years. It's the reason Sydney has beaches at all. The current keeps the coast warmer than the latitude should allow, and right now, it is strengthening. As ocean temperatures rise, the current is intensifying and pushing further south, delivering warmth to latitudes where, historically, it would have started to fade. The 20-degree thermal floor that defined the bull shark's southern boundary is moving. Not fast, not all at once, but measurably year after year in one direction. Researchers modeled what this means specifically for bull sharks. Using a decade of fisheries and bather protection data from New South Wales, they projected the future distribution of the species as the current continues to strengthen. The result was specific. By 2030, the Nes Davos coast will offer 3 additional months of thermally viable habitat for bull sharks compared to 20 years ago. 3 more months, every year. At latitudes the species previously used only as a passing edge, we are inside that window now. But here's where the investigation gets complicated, because the strengthening current doesn't fully explain everything the data is showing. And when researchers try to account for the rest, they arrive at 3 separate explanations, each credible, none of them complete on its own. The first is the one we just described. The thermal boundary moves south. Bull sharks follow livable water as it expands. The map gets redrawn by physics. The second is about how these animals move. Bull sharks don't fight a current to cover long distances. They use it. They hold position in the water column, read the surface flow, and drift, expending almost no energy while covering distances that would be impossible through active swimming. A bull shark entering the East Australian current north of Sydney, waiting for the right moment, can be carried south by hundreds of kilometres on minimal effort, and if it arrives somewhere that now, for the first time in recent decades, has enough residual warmth to make staying viable, it stays. The third explanation is the quietest one, and in some ways the strangest. What if some of these animals were never fully absent from southern latitudes to begin with? The acoustic monitoring array along the Nes Davos coast was not designed to detect sharks at the edges of their range. It was built for beaches where sharks and swimmers already overlapped. South of the last monitored station, the coast continues for hundreds of kilometers. Estuaries go months without formal survey. River mouths sit unwatched. A bull shark moving through an unmonitored estuary in winter generates no data point. The researchers who documented the marimbula detection made this explicit. Absence from the record is not the same as absence from the water. What looks like an advance may be, in part, a rediscovery. Animals that were always thinly present, in waters that no one was watching. 3 explanations, all pointing the same direction, all being amplified by the same underlying force. A surfer who had been in the water at the same breaks for 30 years told a reporter after the January attacks that he didn't recognize the ocean anymore, not the conditions he knew. The number of animals, the frequency of encounters. He wasn't speaking as a scientist. He was speaking as someone who had enough data points in his body to notice when something had shifted. A fisherman at Camp Cove, a family beach in Watson's Bay, pulled a 200-kilogram bull shark from the water while people were still swimming behind him. He said he found them quickly after arriving, and that there were 2 more circling near the boat while he fought to bring the first one in. These aren't horror stories, they're data points. And the pattern they form, alongside the peer-reviewed literature, alongside the modeling projections, alongside the acoustic tracking results, is consistent in a way that's difficult to dismiss. Something is different. The people in the water know it. The researchers tracking the animals know it. What nobody has fully pinned down yet is exactly how much of what's different is temporary, a cluster event driven by rain and baitfish, and how much of it is structural. A baseline that has quietly shifted. The researchers who study this are not asking anyone to panic. Bull sharks have always been in the coastal systems of New South Wales. They have always moved through Sydney Harbour after rain, always congregated near river mouths, always been present in greater numbers than most people realise. The January 2026 clustering was most immediately explained by what heavy rainfall does to nearshore water. It flushes nutrients, draws baitfish, and pulls predators in behind them. That's real, and it explains the acute event. What it doesn't explain is the marimbula detection. What it doesn't explain is a decade of increasing bull shark occurrence in Nes Davos commercial fisheries data. What it doesn't explain is a modelling study that projected exactly this southward expansion, years before the 2026 cluster made headlines. The acute event is the storm. The structural shift is the tide. By 2030, based on the current trajectory of the East Australian current and ocean surface temperatures, bull sharks will have access to 3 more months of viable coastal habitat along NS Dodlas than they did 20 years ago. 3 months in which an animal that was previously a seasonal visitor at these latitudes can function as a resident. That's not a distant future. That's 4 years from now. And the monitoring infrastructure, the drones, the drumlines, the acoustic arrays, the Shark Smart app downloaded 430,000 times with 68,000 new installs in January and February of 2026 alone, that infrastructure is going to keep generating data. The next confirmed detection record further south than Merimbula is not a question of if. The coast below 36.9 degrees south is long. A lot of it is not monitored, and the current that runs along it is getting warmer. If you've been in the water along the Nes Dadlo south coast or Victoria's east coast and seen something that didn't sit right, a shape that moved wrong near a river mouth, a disturbance where there shouldn't be one, tell me where in the comments. The formal record has a line. The line is almost certainly not the end of the story. Subscribe. The map is being redrawn. We'll be watching when the next mark goes down. There's one more layer to this that the mainstream coverage of the January attacks didn't touch, and it's the part that reframes everything that came before it. Bull sharks in Australian waters are listed as vulnerable to extinction on the IUCN Red List. They are caught as bycatch in commercial fisheries. They are a designated target species in the shark net and drumline programs running off Queensland and New South Wales beaches. Programs designed to reduce attack risk, but which remove animals from the population every season. Globally, roughly 1 million bull sharks are caught annually across all fisheries combined. In Queensland's own shark control program, the average size of captured bull sharks has been declining for years. That's a signature biologists recognize, a population losing its largest, oldest individuals, faster than those individuals can be replaced. A species under that kind of pressure, expanding southward into newly viable habitat, is not a population exploding. It is a population finding the edges of space that have just become available to it for the first time. That distinction matters for how you interpret what the data is showing. When a surfer at Crescent Head says he's never seen so many sharks, he may be right. But more sharks and the boundary is moving are not the same claim. What the research is pointing to is more specific, that the thermal envelope within which this species can survive and persist along the east coast of Australia is expanding, slowly and measurably, in a direction away from the tropics. The animals aren't multiplying overnight. The space they can occupy is growing. And a species that can live in fresh water, that uses river systems as nurseries, that follows current corridors south with minimal energy expenditure, is positioned, more than almost any other marine predator, to use that expanding space as it opens. In October 2024, before the January attacks made international headlines, a tagged bull shark from the Nes Dadlo monitoring program was detected north of its tagging site in Eurobodala, then south of it, then north again, mapping a movement pattern along the south coast that researchers described as consistent with exploratory range behavior. It wasn't a shark lost and disoriented. It was a shark checking the territory. Whether that territory will hold it remains to be seen, whether the water stays warm enough, long enough, to make that range viable year-round. That's the question the next 5 years of data will start to answer. What is already answered is the direction of travel. The thermal boundary that defined the southern edge of bull shark range in Australia is not fixed. The current that sustains it is strengthening. The animals that use that current are moving with it. The map is not wrong exactly. It's just behind. Here's what that looks like in practice. The Nes Dadlo south coast is not a remote wilderness. Merimbula, where the southernmost confirmed detection was recorded, is a town people retire to. Families surf there. Fishing boats work out of its harbour. People swim at its beaches on summer mornings without thinking twice about what might be in the water with them, because the maps and decades of experience have told them that bull sharks don't come this far south. Those maps were built on real data. They reflected real biological limits, but they were also built at a specific moment in time, using the temperature gradients of a specific ocean. That ocean is not the same ocean it was when the maps were drawn. The researchers who documented the Merimbula detection didn't publish it as a warning. They published it as a finding, a data point that extended the known range of the species and that needed to be integrated into the models going forward. That's how science works. The record moves, the maps get updated, and the next version of the map reflects a reality that the previous version couldn't see. What the next version of the map is going to show, how far south the boundary eventually settles, whether it stabilizes at a new latitude or continues to move, is the open question. The East Australian current is not slowing down. The ocean surface temperatures along the NS Dallas coast broke records in 2024. The modeling that projected 3 additional months of viable bullshark habitat by 2030 was published before those record temperatures were recorded. It may be a conservative estimate. The people who will have the earliest indication of where this is going are not the scientists with the acoustic arrays. They're the surfers, the fishers, the divers, and the coastal residents who are in the water every day along stretches of coastline that no monitoring program covers. The people who notice a shadow in a river mouth that doesn't belong. The people who pull in a catch they weren't expecting. The people who have been reading the same water for 20 years and feel, without being able to explain it, that something has changed. The formal record ends at 36.9 degrees south. Below that, the coast continues for hundreds of kilometers. Some of it is monitored, most of it is not, and the current that runs along all of it is getting warmer every year. Whatever is down there is not waiting for the map to catch up.